The fuel oil system. The fuel is supplied by the engine and motor driven by the supply pump, which draws the fuel from the tank of the suction. It shows in the figure 9 the fuel oil supply pump. The cartridge type of the filter, metal edged strainers. 2, the metal edged strainers, the motor driven supply pump and discharge relief valve. And a strainer forces the air pressure into the fuel oil head where it supplies the injection pump to the gravity from return to the line from the header. The pressure valve relief of the fuel pressure in the header of 25 psi, passing the excessive fuel bank back to the tank. The supply pump protected against the pressure of the relief valve connected and discharges the suction strainer and the filler of the cartridge with the clean and renewed periodically. The fuel storage tanks and the filler gauges are located on the rear locomotive. The center tank is added with the AS616 model in the fill tank, slowly observing the level gauge to the overflow. Lube oil pressure shutdown device. The safety device incorporated with the fuel system shut down the engine if the low pressure is too low. Electronically control the engine shutdown. The valve is fed through the lube oil. Figure 10 and 11, you see the rear fuel tank, multiple unit engine receptacles, and the center fuel tank. Figure 10 of the fuel is one is the fuel oil, the 2 the fuel gauge. 3 a training line receptacle, multiple units. Center fuel tank of the fuel oil filter number 1. Fuel gauge number 2. Pressure switches, which is kept in the closed in the lube oil pressure, then shut down the energized fuel tank control. See that they are according to the demands of the government. The lube oil pressure drops. Switch opens. The shutdown valve is de-energized, and it forces position of the force of the fuel control shaft to stop the no fuel position, which engine is being started. The engine start button energizes the shutdown valve by pressing the lube oil switch, but maintaining the fuel supply until the lube oil pressure builds up the normal possible causes of the lube oil pressure are given in the operating difficulties rear of this book. Here's a fuel oil system diagram in 12. I'm not going to read it. And here's the number of lubricating oil system diagram. It's on the side. I'm not going to read it. I'll read you the lubricating oil system. Lubricating oil is drawn from the sup of the form to lubricating sup from the form to the bed plate of the engine and through the suction strainer of the engine driven pump. The pump forces the oil through the oil filter and metal edge strainer. The heating exchange of the oil is delivered to the engine header that distributes the oil parts and the parts of the engine. During the requiring lubricating, the pressure gauge of the cabs should be between 50 to 55 pounds, equivalent to 65 pounds, as the header should pressure an excessive relief of the valve of the spill, the output of the engine pressure, engine base enough the relief of the pass, the heat exchanger, if the base drops in excess of the water connection of the heat exchanger is shown in the cooling system diagram. The oil level and stuff should be checked daily, most of them maintained above the low marks to fill the crankcase board of the properly type of the oil through the filler pipe to fill the fuel mark and the bayonet gauge to drain the oil engine. Drain from the oil engine, open up the drain valve, remove the plugs from the bottom of the crankshaft too. Also be sure to drain the strains, the filter and heat exchanger when the changing of the crankcase. Over here you see a cooling of the water system. It shows the water filter, the expansion tank, the ventilation lines, the overflow and vent, the radiator, the lube oil, heat exchange, the drainage and the fill life, the turbocharger, the cab heater, the shutoff valve, the drain valve, the water pump, the diesel engine, the water inlet header, and the water outlet header, and the water level gauge. Water circulated through the engine heat exchanger and the coolant radiator engine-driven pump, the extension tank, the vented to the atmosphere through the overflow of the pipe, the reserve, the maintain the fuel system water level, and the expansion tank must be maintained above the bottom of the gauge. The gauge is on the radiator compartment bulkhead of the temperature control given in the equipment at the front of the engine compartment. If the leak is suspected, the crew should endeavor to locate the way the engine is warm and report to the maintainer. However, the packaging glad of the water pump is adjusted for the leak of about 3 or 4 drops per minute normally. To fill the system, add with the water for the fuel, add water to the connection located over the number 1 truck of the right side of the locomotive. This system has been filled through the filler of the roof near the front of the, but is not recommended because of the drain trapping of the engine system. The engine over the heats of the lower water level in the idler and add the water if possible necessary to use the cold water. It should be available to slowly drain the drainage. If the locomotive is not left standing exposed to the freezing temperature, it shouldn't be necessary to drain the cooling system in the outside source step and to prevent freezing. If the steam source is available, connect the drain pipe to check the valve until the water not back up in the steam line on the drain valve enough to allow the steam to enter the system. Drain the system, open the drain valve in the figure 16. Also drain the heat exchange in the cap heaters and turbocharger cooling system, condensing water in the accumulated turbine casing in which the separate devices drain valve. Fan switch. The fan switch is a small double throw manual operated switch. Is manual front switch on the front panel of the front wall cab, and in 3 positions the fan connectors are connected with the following. The off position fans will not operate. Automatic position the fan is automatically regulated. On position the fans operate immediately. Speed automatically. Temperatures control the circuits. The shutter provided by the dynamic braking to determine the path, not volume of the air filter. The part of the water temperature controls. The figure 17 shows the dynamic brake locomotives. The equipment of the radiator bulkhead shows the shutter magnet valves. The shutter limit switches. The shutter operating cylinder with 4 of the lower flaps and the shutting operator cylinder for the top side shutters. Automatic temperature control when the fan switches from the auto position radiator fans with the driven electrical motors whose speed for the variated thermostatic control of the fan motors. When the water temperature rises moderately, the fan controls that which operates the flow voltage. The further rise in temperature closes the contactor and connects to the full generator valve voltage and fans. They're increasing their speed, and the full increase of the temperature gauge and the contactor should shunt the fans and motors that is still faster than the operation as the water cools to the fault fan. The speed of the automatic decrease. Main control of the automatic system does not functionally properly when check the fan motor, the breaker, and fan of the are not running position. Not automatically cooling may be had of the moving the position 3. The switch on position the fans run immediately to speed if and the water pump in the idler bracket. Figure 18 chain idler adjustment bracket pumping casing impeller nut and left-handed thread and pump section in the head. Electrical system. Electrical drive most practical means of transmitting the diesel engine power to the driving the wheels. Electromagnetic provides the simplest means of the handling both the propulsion of the motors and auxiliary equipment. Now normally operation and control by the throttle reversal and standing brake of the system. The manual operated switches are set for the normal operating engine started. The previously described power is controlled by the throttle auto load fielding shunt of the engine controlling as are controlled automatically. Operating should have some of the fundamental knowledge of the electrical system is the most component handled the controls indicating the instrument is the prevention of the trouble than meeting the routing entering operation conditions when they arise. Most of the instrument routing and controls are mounted on the panels in the front of the engineer, illustrating the inside of the equipment of the cabinet. Near from the front of the book shows most of the other electrical equipment of the locomotive. The controls should be thoroughly understood with the investigation repairing any trouble with high voltage on such much of the equipment. No attempt should be made either to enter the cabinet without taking proper satisfaction precautions. Some equipment is mounted on the engine room side of the cabinet frame. The diagram of the principal equipment is control system is shown in the details proposed omitted so the essential relationship are made more easily used. The master control consists particularly with the throttle reversal lever. The main generator supplies the high voltage power. The traction motor, fan motors, the auxiliary generator, the battery supply lower voltage and above 75. The lighting of the controlling circuit of the four pole exciter field the circuit. When there is more than one diesel engine controlled with one controller, the only circuit electrical connections between the units and the low voltage circuits. The principal type of the control equipment functions as follows. Relay is a coil which opens as closely as the comparative light contacts. Generally, in controlling circuit of this coil may be either high voltage, low voltage, and circuit may be adjusted. The pickup drop in the various voltage calibrated by the responding very operating conditions. The name impels the release impulse of the other equipment. Most contactors are more than one contactor may be controlled by a single relay. Contactors. The contactor is cool operated as set. The contactor's general heavy due to the circuit breaker control that is close and open, generally depending on whether it's energized or de-energized. Usually non-adjustment for the intermediate voltage and current because the most sensitive relays are used in such a purpose. The light duty contact with the contactor collected with the electrical light duty contacts on a contactor are called interlocks, which are described in the next paragraph. Interlocks are auxiliary switches that mounted on the control with another switch is the controller valve of the similar control equipment, or operated by a cam or mechanical linkage, which is connected with the opening and closing of the auxiliary circuits depending on the operation equipment. The main circuit, and they are using to control the sequence of the operation to permit the making of the breaking of the related circuits in which the properly conditions except the chief concerns the operating for the sluggish, faulty interlocking causing the faulty locomotive operation. Electro-pneumatic valves. Electro-pneumatic valve consists of the electrical coil of the control circuit, which controls the valve of the pneumatic operation of the certain equipment with, for example, the reverser power switches, pneumatic operated valves, which is built in the equipment control air pressure maintained at the main air reserve but at the low pressure. The voltage regulator and battery protection. A voltage regulator holds the auxiliary generator voltage constantly over the normal speed range of the diesel engine as is slightly above the battery. The voltage battery will charge if necessary. A reverse control relay protecting the battery against the discharge through the idle defective auxiliary generators. The relay opens the contactor of the circuit whenever the reverse control flows. The contactor closes automatically at any time generator the voltage exceeds the battery voltage. Operators should not change the adjustment and setting of this equipment. The principal item of the equipment of the rear of the cabinet, the wheel slippage, the slide single arm relay, the ground relay, the time delay, the air relay, the K3 pneumatic switch, the throttle valve, and the air standard locomotive's power knockout contactor is installed with the dynamic brake locomotive to the monitoring section of the valve brake selector valve. Control system diagram. Condensed sequence operations. I'm going to increase this to 125. Stage operation starting electrical action. The main generator is connected to the battery wires not shown in the diagram. It acts as the motor turn on the crank of the engine. Other generator connections are open. Pneumatic action none. Engine idling after the starting of the electrical action. After the starting and closing the electrical generator field switch, the auxiliary generator is connected to the battery. The main generator field, the exciter of the field energizes the automatically closing the field. The engine cooling, the fan motorized contactor closed, the fan operating when for the radiator hot enough for the fan speed automatically changed for the temporary switches which energize the various combinations of the fan motor contactors. The pneumatic action and the magnetic valve controls the shutters. The reverse lever is set to change the direction. The electrical action, the reverse magnet valve connection establishes most energized. The throttle is advanced in the next step. The pneumatic action is the operation of the cylinder moves to the reverser. The reverser valves are energized after the throttle. The throttle advance. The magnet valves and the reverse of the traction motor contactors and P switches are energized. The pneumatic action and the full supply increase the engine speed. Seeing the pneumatic lines of the diagram power switches closed and the magnet valves are energized. The running eye and high speeds, the motor of the fields, the electrical action in the motor of the field shunted by the closing of the field shunt contactors to the M, and the 4 steps of field shunting sequence control responds to various generator voltages, speed changes to see above the non-additional action. Throttle retarded is the stage of operation. Reverse of above, electrical action and pneumatic action. Wheel slippage pickup there. Sensitive to unbalanced voltage condition of the traction motor closing the circuits and organize the valve of the throttle like the throttle lines of the pressure reduced of the fuel system supply reduced automatically restored with a slipstone. I'm gonna back out of this 1%. Here's your master controller to the wheel slippage and an identical path to the auxiliary governor. Then it splits from the governor to the load regulator and the fuel injection pump valve to the engine, which then settles it in between the generator and exciter field and exciter, while it's done parallel circuits and between the battery and the auxiliary generator, which frame from the wheel slippage control equipment pneumatic. These double lines are given to the drawn from the master control to the control equipment, the pneumatic and electrical. The generator is followed by an inward circuit path of fan motors and contactors, fan motors, and traction volt motors and contactors. The double line is a control circuit, low voltage. The solid black line is the power circuit, high voltage. The pneumatic line is a dotted line. Sorry, I got that wrong. And the leakage is a evenly spaced line. That's figure 22, the control system diagram. Dynamic braking.